So the GIF here in question, I want you to describe how this GIF demonstrates Newton's first law. I also want you to try to recite Newton's first law. A good idea while you're watching this video is to maybe pause me because I'm just going to plow ahead and explain each of these GIFs and each of these slides, and then maybe think of your answer, and then go ahead and replay the video so that you can hear what's going on. So Newton's first law says that an object in motion will stay in motion, and an object at rest will stay at rest, unless acted upon by an outside or unbalanced force. There are three ways this is demonstrated in this video. Number one is the snow. The snow is at rest as soon as the snow is being pulled down by gravity. It's being pushed up by the fence, and those forces are balanced, which means it's at rest. Now, as soon as the fence moves out of the way, the fence can't push up anymore on the snow, so the snow falls down because gravity is an unbalanced force acting on it. Number two, the boy here, he is in motion. He's an object in motion until he is acted upon by an outside or unbalanced force. That's the fence. The fence is pushing back on him, and it makes him come to rest, makes him stop. Third object is the fence itself. It is at rest, and it stays at rest until it's acted upon by an outside or unbalanced force, that is the boy hitting it. So you might notice this is also illustrated in Newton's third law. The boy pushes on the fence also applies a force back on him. So Newton's second law, we talked about yesterday how it's really just a formula, F equals ma. And I'm going to add a definition to that that's not a nice, easy one to remember. What it says is the acceleration is proportional to the force, and it is inversely proportional to the mass. Now that sounds kind of wordy, it's a little bit hard to grab onto. Let's talk about this first part. That word proportional. You might think about math class. You've probably heard that word proportions or proportional in Miss James' class before. An example I used in class is that my shoes are proportional to my height. That means I'm a really tall person. I also have big shoes, big feet. Somebody who's short might have small feet. Foot size and height are proportional. Another way to think about it is this lawnmower. If you push the lawnmower with a lot of force, it's going to have a lot of acceleration. You push it with a little dinky force, a little tiny bit of force, it's going to have a very low acceleration. And then the flip side of Newton's second law is that acceleration is inversely proportional to the mass. So let's imagine this guy is pushing the lawnmower with the exact same amount of force as he's pushing the car with. What would you expect the acceleration to be for the car and for the lawnmower? Well, lawnmower has a small mass, so it has a high acceleration. The car has a high mass, so it has a low acceleration. That is what inversely proportional means. It means as one quantity goes up, the other quantity goes down. And then if we go back to this GIF that we watched the other day, this is a great demonstration of Newton's second law. They both experience the exact same reaction force, the girl and the guy. However, she has way less mass, so she experiences way more acceleration. Whereas he has a higher mass, so he experiences less acceleration. So equal force, different mass, different acceleration. Same with this one right here. The guy on the right has a lot more mass, the guy on the left has a lot less mass. So low acceleration, high acceleration for the little guy. Okay, we're going to go to Newton's third law. If you remember from yesterday, we talked about the definition. We'll go ahead and write it right here. For every action, there is an equal and opposite reaction force. Let's see if I can get that word in here somewhere. Okay, reaction force. That last word is really, really important. Going back to this, if you just said equal and opposite reaction, you might expect both of these guys to fly back the same amount in the opposite directions. However, they don't. This guy goes a little, that guy goes a lot. That's because the reaction force is the same, but the mass is different. So it's really important to add that word force and understand why that word is there. Our first example is Wally over here. Let's see if he wants to play. So Wally is demonstrating Newton's third law. He sprays the fire extinguisher that way, and the gases push him the opposite direction. On the boat here, when you want to jump off a boat, you push the boat that way, and you go forward. So if you're going to try to move forward, you need to push something else back. A lot of people probably fall in the water that way. And then finally is the gun here. So this guy is firing a bullet from a gun. The bullet goes to the left. That's the action force. And if the bullet needs to go to the left, it also needs to push back on the gun. That's the reaction force. We usually call that recoil or kickback. That reaction force pushes back on the person. So you have to be careful not to hold a gun up to your face or to your collarbone because you could break those with that recoil force. Okay, now what I'm going to do is I'm going to go through a whole bunch of GIFs, and like I said, you might want to pause these and identify which of Newton's laws it's primarily demonstrating before unpausing it and listen to see what I say about it. So here is the first one. I showed this in a couple classes on Monday, but not all of the classes. This is demonstrating Newton's first law. The car is not in motion, and they forgot to put the parking brake on, and so it stays at rest. It starts at rest, it stays at rest, and while the truck moves forward. A good idea would have been to strap it in or to put the emergency or parking brake on rather than just leave it in neutral. Okay, next one. This GIF right here. This GIF is primarily illustrating Newton's third law. He fires the bullet that way, the bullet gets pushed that way, the bullet has a reaction force back on the gun and on him in the skateboard and pushes him back. You could also say that it's Newton's first law because right now he is at rest. He stays at rest until he starts applying the force on the bullets. You could also maybe say Newton's second law, that it takes a lot of bullets with little mass to apply force on him. Every single bullet doesn't really push him all that much. Next up is this GIF. This GIF is demonstrating Newton's first law. He applies force to the trampoline, it makes the trampoline move. It was at rest. However, he doesn't apply force to the leaves, so for a split second there, the leaves are kind of at rest, just in the air, until gravity meaningfully accelerates them downwards. This is it's kind of first and third, Newton's first and third laws. I wouldn't expect you to necessarily be able to wrap your brain around this just from watching the GIF. This is a cannon in the back of a pickup truck. This is Mythbusters. They fire the cannon. They know the cannon shoots the ball 40 meters per second this way. So they drive 40 meters per second this way, the opposite direction. And when they do that, their motions cancel out. So balanced force is 40 meters per second that way, 40 meters per second this way, means that it just drops straight up and down. So that's a little bit of Newton's first law, a little bit of Newton's third law actually there. This guy right here is demonstrating Newton's third law. He kicks the car and applies a force to it. It also applies a reaction force back on him. Foolish decision on his behalf. You could also maybe say Newton's second law, that it has a lot of mass, so it can apply a large reaction force to him. You could maybe also say Newton's first law, that the car is in motion and it just continues in motion. And he's in motion until he's acted upon by the force of the car. And this one right here is illustrating really maybe two of Newton's laws meaningfully. The first is the dog jumps this way and he pushes the boat back that way to the right. That would be Newton's third law. And the other one is while the boat's going backwards, her motion continues forwards. She just keeps on going the direction that she's going. That would be Newton's first law. So I'm going to say that this is both Newton's third and Newton's first law. If you wanted to think about Newton's second law, you could talk about how the dog doesn't have a lot of mass, so he doesn't push the boat a lot, whereas she has a lot of mass, so when she jumps off the boat, it pushes it by quite a bit. This guy is a Darwin Award candidate. He did not realize that when he smacked the windshield with the bat, the windshield would also smack the bat with the equal and opposite force, putting the bat right in his face. This is Newton's third law. This one's similar to our leaves and to the snow. This is Newton's first law. And I showed this to the classes too. This is a guy who decided it'd be a great idea to jump off the moving train, not realizing that he was an object in motion right up there, and he stayed in motion. So if the train was going 40 miles an hour that way to the left, when he jumped off the train, he was also going 40 miles an hour to the left, and he almost hit that big concrete pier, and he would have died. That's why we talked about the Darwin Awards in class. He's a survivor of the Darwin Awards, which is usually awarded to somebody who does something really stupid and does not survive from it. Okay, the last thing that we did today then is we spent a little time. We went to LMS topics and forces. There's a simulation here. I've got a worksheet that kind of walks you through how to use this tug of war game to learn a little bit about Newton's first and second laws. So it'd be a good idea for you to get that sheet from me at school and maybe spend a little time tonight or tomorrow night working on that. We will be doing the slingshot lab tomorrow, Wednesday, in class, and we will probably have a quiz before we do that, so make sure you've watched the pre-lab video. Hope you all have a good day today. Bye.